This training video is an introduction to Die 101 training for our Nordson dies. We will go over the nomenclatures, die assembly, torquing, heating the dies, end seal materials, and lip adjustments. This is just a basic overview, but these are some of the questions we get asked about the most. For nomenclature, this is a flex body. We call this the flex body because it has a flexible hinge, and this is where the lip gap is opened and closed. This is the non-flex body because it has no flex hinge here at this point. This is our manifold, the back of the manifold end sweep. This is the throat or the entrance to the manifold, and this is the pilot to the entrance of the manifold. This is the pre-land, the secondary manifold, the final land, the lip edge radius, and the die face. This can help when you're trying to describe a certain spot on the die to someone at a different location. It's better for everyone to know the names of these areas so there's no confusion as to what part is being talked about. If there are any specific areas on your die that you have any questions about, let us know here at Nordson and we will be happy to help you with that. We will recap a little from the Nordson Split and Clean video by saying there are a few highlights that we will talk about. If you have not seen this video, please contact your Nordson representative to receive a copy of this. Once the die has been cleaned, we would like a person that knows what they're looking for to inspect the die to make sure that all the parts are cleaned thoroughly. Some of the areas that get missed on the die are the end sweeps, the back of the manifold, the lip face, the throat, the entrance, the ends of the die here, and the seals. Once it is checked and approved, the die can be reassembled together. If there are any decals, they will need to be cleaned and looked over also. If any of the heaters need to be replaced or have been pulled out of the die after the die has been running, then the heater needs to have a heat transfer lube reapplied to the heater. Please note that this is not an anti-seize, it has been formulated for heat transfer. A very thin coat of transfer lube will be just fine. We just want to talk about the anti-seize on the body bolts. You want to make sure you're putting anti-seize on the threads and above and below the washer. This is now a properly anti-seized bolt. We cannot stress enough that you need to keep lip protection on the die at all possible times. We have many dies out there that have damage to the faces, final lands, and front edges. No matter how careful your people are, bad things happen very quickly. If you are prepping your die for storage, then you want to make sure that you are putting the proper rust preventative on the die before you put it into storage. We suggest that you cover the entrance and the exit of the die. This will prevent air and debris from entering the die. Again, lip protection is required. In this portion of the video, we wanted to discuss the torquing of the die. There are different tools to use to torque your die. This is a hydraulic wrench. We recommend using this type of torque wrench because it will deliver a more even torque across the die. This wrench is for installing and removing body bolts from the die. This is a pneumatic torque gun wrench. It looks similar to an impact gun, but it is different. This is a good wrench to use. You will need to make sure that you can supply it with enough air pressure to do the job. This wrench is for installing and removing the bolts from the die. This type uses a torque wrench and a multiplier, which uses gears to multiply the torque from the wrench to get you the torque you need. When using this type of wrench, you must be careful to stop when the wrench clicks and do not go past the mark, which is sometimes hard to do. This is a straight torque wrench. This wrench will work, but only if you get one that has a high enough torque rating. This wrench is not big enough for the torque you need. We are using this one as an example. When using this type of wrench, you must be careful to stop when the wrench clicks and do not go past the mark, which is sometimes hard to do. There are straight torque wrenches that will go high enough for the torque that you need. Also, these types of torque wrenches are not typically made to remove the bolts. They are made to install the bolt at a set torque. This is a pipe and Allen wrench. We do not recommend using this, but have had to use this approach in the field. It will torque and untorque the bolts, but there is no consistency in the value of the torque being applied. You need to be very careful when using this option. We have seen people pulling down on the bar and get hit in the head, or pushing down on the bar and getting their hand smashed between the floor and the pipe. When using any of the torque wrenches, please make sure you are following the manufacturer's operating instructions in order to ensure proper and safe use. We would also recommend that you do not use any reducing adapters while torquing the die. That brings up our next point. Make sure that the bolts that you're using in your die are the correct grade. Also, if you're reusing your bolts, check for wear on the threads and check for wear where the Allen wrench fits into them. After in-depth testing, we have eliminated the hot torquing of our dies. We now follow a specific torque procedure and torque the dies at the full torque value at an ambient temperature. We have worked with the bolt manufacturer and have done extensive testing here at Nordson to come up with the new torque charts. We have two torque charts. One is for dies running temperatures up to 550 degrees Fahrenheit, 288 degrees Celsius. The other chart is for running dies over 550 degrees Fahrenheit, 280 degrees Celsius. To correctly torque the die, all bodies must be at equal temperature. Torque the die bodies at 60% of the full torque value located on the torque rating chart. Start from the center and work out to the die ends, alternating each bolt on either side of the center line during tightening. Refer to the startup section in the manual for the bolt pattern. Then torque the die body bolts at 100% of the full torque value and repeat at 100% of the full torque value again. Again, starting from the center and work out to the ends of the die, alternating each bolt on either side of the center line during tightening. These instructions are on the bottom of the torque charts found in your die manual. If your company still wants you to follow a hot torque procedure for your die, this is okay. We have not found any downside to torquing at an ambient temperature. There are upsides to torquing the die this way. For one, safety. Maintenance people do not have to work on the die when it's extremely hot. This also saves time. You do not have to sit and wait for the die to get up to temperature and then bring the maintenance people back in to torque the die. The time saving is especially true if you have a spare die. Also, it makes the people happy. It's not fun to work on these hot dies, and if I don't have to work on a hot die, it's all the better. For new dies and dies that have been in storage for a while, they must be brought up to temperature very slowly to drive off moisture without shorting out or reducing the life of the heaters. Heat the die progressively from room temperature as follows. Room temperature to 100 degrees Fahrenheit, 38 degrees Celsius, and hold for 30 minutes. Then raise it to 150 degrees Fahrenheit, 65 degrees Celsius, and hold for 30 minutes. Then raise it to 250 degrees Fahrenheit, 120 degrees Celsius, and hold for 15 minutes. Finally, raise it up to the die's operating temperature. If you have an autoflex die, once the die is at 250 degrees Fahrenheit, 120 degrees Celsius, you need to turn the autoflex on, and it must also be brought up to temperature very slowly to drive off moisture, without shorting out or reducing the life of the heaters. You want to turn on the powers to 10% for 15 minutes, then 20% power for 15 minutes, then 30% power for 15 minutes, then 40% power for 15 minutes, then 50% power for 30 minutes. Once the die and autoflex heaters are up to temperature, you are now ready to set your lip gap and tighten the end seals. If your die has lip heaters installed, you will turn them on after you've started running the polymer through the die. This is the procedure that you would use every time you start up the die. By slowly bringing up your die to the temperature, you will reduce the risk of burning out the heaters or reducing the life of the heaters. After doing a split and clean on your die, you should also check all of the electrical in your die, including the autoflex heaters if you have an autoflex die. There are several different types of gasket materials that are used on our dies. When the die was designed, the best material available for your operating parameters was chosen. This is your end seal gasket, your end seal plate, and your end seal push plate. To install the end seal gaskets, you will need to move everything up, make it flush here with the lip exit. Finger tighten down the end seal screws. You only want these finger tightened until the die is heated to operating temperature and the lip gap is set. At that time, you can torque your end seal plates down. Once the die is at operating temperature and the lip gap is set, you need to check the end seal alignment with the die lip face. Tighten the end seal plate screws to 12 foot-pounds, 16 Newton meters. Do this 2 times, starting at the lip exit, working your way to the back of the die. Next, torque the end seal plates to 24 foot-pounds. Let stand for 5 minutes at operating temperature. Then retorque at 24 foot-pounds, 32.6 Newton meters again. Carry out this procedure 3 times, starting at the lip exit and working your way to the back of the die, with 5-minute intervals in between the torquings. The torque applied to the pressure screws should be held to the values previously mentioned. Insufficient torque may permit leakage, and excessive torque can be destructive to the end seal components. If external decals are used on the die lips, special care must be taken to ensure the end seal assembly is flush with the die lips. Here at Nordson, we will use 2 different types of measuring tools to gap the die. You can use a brass feeler gauge, or you can use a brass taper gauge. The brass feeler gauges are a more precise tool. You can set the lip gap within 1 or 2 thousandths across the die. The brass taper gauge is a much easier and faster tool to use, but you can get the lip gap set within 3 or 4 thousandths across the die lip, sometimes even better. When adjusting the die lip, you will need to bend the lip smoothly. In order to do this, you need to adjust around 5 bolts. Adjust 1 bolt in the area that you need adjustment, and then adjust each bolt on either side of that bolt in half. And then each bolt on either side of them by half of that amount. This will ensure that there is a smooth bend in the lip and that the lip bolts do not bind against each other. And I will show you. On our push-pull systems, if one of the bolts is pushing too much and the bolts that are next to it are not being moved, it can bind the bolts and cause damage. We see this firsthand when out on our service calls. Something else that we see is if the bolt is bound up, someone puts a cheater bar on the wrench and tries to move the bolt. This is usually where damage occurs. This T-handle is what Nordson recommends using on your die. We do understand that sometimes due to space constraints that different tools may be needed, but make sure that the lever arm is not so long that it will cause damage to the bolt or other parts on your die. When making changes to the lip, you need to make sure that all of the lip bolts are in compression. If the lip bolts are not in compression, there is a possibility that the lip gap will open in those areas. We would like to go over the operation of the restrictor bar. This die has a restrictor bar in the full open position. All of our dies are shipped with the restrictor bars in the full open position. Note that the restrictor bar stud is even with the restrictor bar spool, and this indicates that the restrictor bar is in the full open position. The purpose of the restrictor bar is to be the first or coarse adjustment for the distribution of the polymer evenly across the die, whereas a flex lip is a fine-tune adjustment. When adjusting the restrictor bar, you need to bend the bar smoothly. This is very similar to the lip adjusting sequence. Adjust one stud, then the two on either side of it by half of that amount, and then two on either side of those by half that amount. This will ensure that there is a smooth bend in the restrictor bar and that the studs are not binding against each other. Now that I've moved the studs, you can tell the restrictor bar position by looking at the position of the stud in relationship to the spool. Some of these studs are further down than others. In that location, the ones that are further down would indicate the restrictor bar is restricting the flow in that area.